All right, Wednesday afternoon. School just dismissed. Time to do some math. Getting closer though. I'm at 41. So only 41 to go. 41 is an a cubed minus a b cubed pattern. Anything, everybody knows this, right? But a cubed minus b cubed factors is a minus b times a squared plus ab plus b squared. That's how she factors. So to create a 64w cubed, I take a 4w and I cube it. I used to have a college professor who couldn't say his w's, and he hated problems like this because he couldn't say w. All right, so take away 2 cubed. That's what I'm thinking about. So a is 4w, b is 2. This thing obviously factors as 4w minus 2. Here this says square it. 4w times 4w is 16w squared. There's a plus, so plus. 4 times 2 is 8. Don't forget the w. And that says square b. That's going to be a plus 4. This thing tells you the signs. Trust it. Still equal to 0. So 4w minus 2 is 0. 4w is 2. And w is a half. There's the real solution. It does say off to the left, where you can't see it on the screen, all solutions. So I can actually pull a little bit out of this one to make it a little simpler to work with. I can pull a 4 out of it. Now this will never factor. This piece never, ever, ever factors. I wish it would. But anyways, I get to hit it with a QF. So w is opposite b plus or minus square root of b squared minus 4 times a, which is 4, times c, which is 1. And this piece always has imaginary answers. They're always imaginary. Over twice a 4. So negative 2 plus or minus. Inside this radical is a negative 12. It's over an 8. That's over an 8. The root of negative 12 is going to be plus or minus 2i root 3. So negative 1 over 4 plus or minus 2i root 3 over 8, which simplifies again. Negative 1 over 4 plus or minus I root 3 over 4. And there's that one. On to 40. The hint on 40 is that you should factor out a negative 5 first. If you do that, it becomes z cubed. Let me pull that negative 5 and show it. Not plus anymore. Minus what? 64? Sweet. I'm happy it's what it is. Because now it's the same pattern as I used in 41. So if you glance over at 41, I wrote it down. That's the pattern I'm using. Negative 5z minus 4, because a is z, b is 4. 4 times 4 times 4 is 64. Z squared plus 4z, because I'm supposed to multiply those two together. If you glance over at what I wrote earlier, probably didn't write it down, plus 16, because you're supposed to square that term right there. And again, still equal to 0. This one's easy. That says z is 4. It's as simple as changing signs when you leave. This one's got to be QF'd. So z is opposite b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 16. All sitting pretty over 2 times 1. Inside this radical, if my brain's working right, is a root of negative 48. Both pieces over 2. Root of negative 48 should simplify to 16i root 3. So I have a negative 4 over 2 plus or minus 16i root 3 over 2. And then I finish simplifying the fraction. That's going to be negative 2 plus or minus, what, 8i root 3? There's 2 answers. And moving on with my life to 39, which is another difference of two cubes. It's basically the same as the last one, isn't it? Other than having the -5 out there, I'm kind of glad I did this in this order. I already know the answers, but I got to show all the work. But I know the answers. This is y minus 4 times y squared plus 4y plus 16. And the reason I said it's the same is the only thing that's changed is the variable. No? So anyways, one of my values is y is 4. And again, go through. You got to show your work, kids. I'm sorry. Go through and say y is opposite b plus or minus square root of b squared minus 4 times a, which is 1, times c, which is 16. All sitting pretty over twice a 1. We're going to get the same thing here. We got a -4 over 2 plus or minus I'm just root of a -48 over 2. We simplify that to be -2. That's going to be, I screwed up. That's a 4. Makes that a 2. Fixed it. Glad I did this one, didn't just blindly copy my answer. Plus or minus 2i root 3 over 2. So now I'm at y equals -2 plus or minus I root 3. That should be a 4. Boy, I just need to stop. Y equals -2 plus or minus 2i root 3. I should have given you more room to do that problem, shouldn't I? Yeah, I should have. But it's too late to fix that problem. It's always next year. I'll probably forget about it. Express the following as either a difference of two squares, a difference of two cubes, or a sum of two cubes. Do not evaluate. I don't care what it equals. I care about you doing patterns. That's all I care about. The patterns, by the way, are given to you on the right-hand side over there. But I noticed that this one is a difference of two squares. It is a 5 squared minus a 4 squared, which means I get to use a squared minus b squared is a minus b times a plus b. So a is 5, b is 4. This is 5 minus 4 times 5 plus 4. Seems silly to do this too. By now, though, you guys have already taken your benchmark. Maybe you remember that one problem on there where this shows up. And you maybe remember my note about it being in the wrong spot. There's always one question like this on the actual end of course test in the non-calculator part. And I have watched so many smart kids. Their names might end in Maddox. Their names might be something like ending in a Finch, if you know what I'm talking about. I lost a name here. A Moore girl. A Win, couple of the Win girls. And Win himself. A lot of smart kids, they do all this hard math on problems like this. They actually figure out what 25 squared minus 16 squared is. The numbers are bigger than that, obviously. And all you had to do was follow a stupid pattern. 37, 12 cubed minus 8 cubed. That is a cubed minus b cubed, and it is equal to a minus b times a squared plus ab plus b squared. Just plug in and go. This is going to be a is 12 and b is 8. Oh, man, I'm an idiot. I'm an idiot. I sat here and talked about other kids missing this. It's legit given to you. It's supposed to be 25 minus 16 times 25 plus 16. That's what it's supposed to be. I was off somewhere else thinking about kids who have missed this as opposed to actually doing the problem. Plus, the way I've been doing, I was wanting to take squares of numbers. Anyways, A is 12, B is 8. 12 minus 8. I'm supposed to take A and square it. That's 144. There's a plus symbol, so plus. 12 times 8 is 96. And when I take the 8 and square it, I get 64. That's how that thing factors. Things like this were done because it was easier to compute. That's why. It's actually easier to figure that out as opposed to actually figuring out what 12 cubed minus 8 cubed is without technology. Here's your sum. And the sum of A cubed plus B cubed is A plus B times A squared minus AB plus B squared. I probably taught you the acronym SOAP. Same, opposite, always positive. That's how I presume I'm going to teach it this year. So I've done it for 6 years now. Anyways, A is 15 and B is 10. If I square a 15, I get 225 last I checked. If I multiply them together, I get 150, but I pay attention to that sign. And if I square a 10, I get 100. And I don't care what stuff is. I'm not going to put any of it together. All right, I'm going to stop at 35 because I'm tired and I want to go home. A nerd is wishing to fence in his rectangular backyard. He will not need fencing against his house. He's going to make a three-sided rectangle. If he has 500 foot of fencing, what is the largest area that he may enclose? So what we're dealing with is a three-sided rectangle. We have three real sides, and then we have this side over here, which is the house. You know, a lot of you guys have this as your backyard. That's what your backyard looks like. We'll call the short sides W and the long side L. And the area function is still going to be length width. That's not going to change. The perimeter function, though, the perimeter is two widths plus a singular length. Normally it's two widths plus two lengths, but in the context of this problem, it's two widths plus a length. And I happen to know the perimeter. The perimeter is 500, so I can do replacement. Now what I need to do is I need to solve this for either length or width. It doesn't really matter which one you do it, but solve for length or width. It just makes sense, though, to solve it for length because it's easier. 500 take away twice my width is my length. Now what can I do? I can do something cool. I can use the substitution property. Everywhere I see length, I'm 500 minus 2 width. And what I'm doing is I'm writing a area function written in terms of W, which I get to call a sub W, because all the variables are W's. You may not realize this, and I doubt anybody will ever show you this again. A lot of times I use notation in class. This is actually, if you were actually to write it out using notation, area is length times width, I just kind of lost my train of thought here, but it would literally look like that. Area as a function of width and length is width times length. Anyways, that's nonsense. You ain't need to know about that. That's how you denote more than one variable. All right, so I am replacing my length with 500 minus 2W, wrap 2 or more, and it's still going to be multiplied by W. So area as a function of W is 500W minus 2W squared. Now you can do this in a TI-84, but it takes longer. I want to know the largest area that he encloses. And that's going to happen at the vertex. That's a quadratic. So this right here, it happens at the vertex. So the W coordinate of the vertex would be opposite B, which is negative 500, over twice the negative 2. That should be 125. Now that I have the W coordinate of the vertex, I'm good to go. I can go back over to my diagram. This is 125 foot. That means that's 125 foot. You doing all right today?
Doing good.
I'm not talking to myself. I'm recording.
I think you're gonna video chat somewhere.
Now I had 500 foot of fence. Those two together make 250. That leaves 250 foot for my length. Now the reason I did all that is because I want to know the largest area. Go back to the old length times width, 125 times 250. Which I'm too tired doing my head. I want to say it's 3750, but I'm probably wrong. Oh, nope, I'm way off. 31,250. Something wrong with me. 31,250 square feet. It's actually not a bad sized backyard in the city. An acre is 43,300 something off the top of my head. Don't remember the exact number, but about 43,000 square foot. So it's 3/4 of an acre for a backyard. It's nice if you live in the city. And that is through 35. Have a good night.